we have Harish Kumar, Senior Cloud Architect at Google Cloud, to talk about the importance of security your API, what, why, how. Thanks for your time.
Thank you, API Days Hong Kong, for giving me this opportunity to talk to all of you and talk about API security threats. My name is Harish Kumar, and I work as Senior Cloud Architect at Google Cloud. I have about 18 years of experience in the industry, and for the last 9 years, I have been helping companies implement secure API practices. Today, we are going to talk about some of API security considerations. The study done by Gartner states that API abuses will be the most frequent attack vector, resulting in data breaches for enterprise web applications. And this requires all API providers to start thinking about security as first thought for using APIs for the digital experience, and think about how APIs fuel connected experience that customers demand, and why delivering connected experience may require new security approaches, and how API management can provide the control and visibility enterprises need. There are a lot of different considerations to make while trying to secure your APIs. For example, traffic management and denial of service attack, application identity, user authentication and authorization, injection and database attacks, data confidentiality, and API security compliance, to name a few. There are various actors involved in providing a secure and useful APIs, such as the user who is consuming the APIs from an app, and the app developer who is utilizing the API to provide a functionality, the API team who are developing the APIs, and the backend that works as single source of truth. And while developing an API, we need to consider various aspects of securities for each and every layer and actor in this lifecycle of API. For example, for the users, we need to think about protection based on usage patterns, payload complexities, and etc. For apps that are going to access the APIs, we need to think access control. And for API developers, considerations have to be made for self-service and single sign-on. For API teams, security governance, and for backend needs, to consider setting up mutual trust to access and provide data in a secure way. From the survey, another interesting aspect or insight that we found was about or around the API threats and the type of API threats which are at the top level. And we learned that the top three API threats, according to IT executives, are misconfigured APIs, outdated APIs, and the bot attacks. And it also aligns with the external report that claims that primary cause of API attacks is misconfigured APIs and too many APIs to govern. Now, using an API management product can surely help and facilitate better protection of APIs. For example, continuous learning and securing the APIs is important. The user can define security profiles and attach them to their environments, and advanced API security will continuously evaluate the API configuration and API traffic in order to score and provide recommended actions. A profile is a set of security policies you want your APIs to uphold to. The recommended action would be what policies you could define on the APIs in order to better secure them. Let's see some examples of some profiles. For example, requiring and verify OAuth policies, which means that every API you define should have this OAuth policy defined. Requiring low traffic and malicious sources. Requiring mutual TLS with target backends. That is, whatever backend APIs or backend systems your APIs are connecting to should consider a mutual TLS, and without that, it should not be propagated to production. Some of the example of recommended action could be to improve authentication enforcement policies in APIs, add traffic protection to APIs, use shared flows with traffic and threat protection policies, and to have some consideration about blocking attacking IPs from where the threat is originating. Next, we focus on bot and abuse detection. In real-time traffic, here, we aim to reflect who consumes your APIs and detect any intruders or abuse to your system. There could be various type of bots. For example, flooders, brood guessers, static content scraper, OAuth abuser, robot abuser. So the automated system should be able to detect all these different kind of attacks and should be able to learn from it and use some machine learning models to enhance this security and to detect automated tools and provide suspicious API traffic protection and also provide visibility into different traffic patterns which are coming to your APIs. Now, API ecosystems experience various attacks from both external and internal clients. Offering and using APIs create tremendous opportunities for service providers, but it also poses some security risks. Developers must be aware of these challenges and address them when they create and use APIs. OSAP is an open community dedicated to helping organizations develop, purchase, and maintain trusted applications and APIs. Through the OSAP API Security Project, OSAP publishes the most critical security risk to web application and REST APIs and provide recommendations for addressing those risks. For example, broken object level authorization. Insufficient authorization validation of an object access request allows an attacker to perform an unauthorized action by reusing an access token. This threat is caused by an improper configuration of authorization validations. API management product provides verify API key, verify OR tokens, and JSON web tokens policies which help protect against these vulnerability. Yet, it is critical that these policies are correctly configured to prevent this threat. To prevent this threat, it's important that application development and security team collaborate closely. Authorization is by nature a complex topic, and effective fine-grained authorization requires a deep understanding of the application's business logic. Next, let's look at broken user authentication. A badly implemented user authentication policy allows for the attackers to impersonate legitimate users by taking advantage of implementation flaws in authentication implementation. Some authentication principles to bear in mind when implementing authentication are: always authenticate both the user agent, that is the app where the user is using, and the user who is using it. Use delegated authentication and authorization patterns and avoid passing passwords directly within an API request. Always validate the signature of access credential and ensure that all access credentials used have a defined expiry time. Prevent brute force attacks by setting quotas and using detection and alert to detect and respond to bot-driven brute force attacks. Excessive data exposure is one of the major issue when you're creating an API. A published API might expose more data than necessary, relying on the client app to perform the necessary filtering. If an attacker directly queries the underlying APIs they are able to access sensitive data. The outside in design principle of API design is data parsimony. Work with your UX designer and developers to only expose the data via APIs that are needed within your app. Backend systems weren't built for public usage patterns. So one of the first tasks of API first design is to reduce the data exposed to the minimum necessary amount to provide a great API product for your customers and developers. Another one of the API design principle is reusability. Security concerns aside, relying on an app to filter the data provided by an API results in the requirements to port that filtering logic across every platform you develop an app for. From a security perspective, this threat results from delegating authorization enforcement to an app, often, however, on a platform or operating system over which you have no control. We have already examined two of these threads and the importance of correctly implementing authorization and authentication to avoid unauthorized data access. Some of the things to consider here are rewrite requests and responses to backend services to minimize the data exposure. Implement fault handling to prevent verbose error messages from exposing sensitive environment information to attacker about your backend services. Now, lack of resources and rate limiting is another major issue which you can face when you're exposing your APIs. By not implementing proper rate limiting policies, attackers can overwhelm the backend with denial of service attack. This threat can be easily addressed by using the following API management features like quotas and spike arrest policies as a preventive control to place traffic limits on inbound API requests, having advanced security and WAF protection to dynamically detect and respond to the bot driven traffic or attacks, advanced API monitoring and alerting as a detective control to be alerted to DDoS attack in progress. Security misconfiguration is another important aspect to consider. And security misconfigurations are easy to overlook, often because administrators and developers mistakenly trust the system they are using to be inherently secure. Security misconfiguration can happen in many different ways, such as trusting default configuration or making partial configuration that may be insecure, letting error messages contain sensitive details, storing data in cloud without proper security controls, misconfiguring HTTP headers, and so on. The API management platform can provide a number of mechanisms to help you control, manage, and monitor security configurations. For example, using a shared reusable flows. A shared flow lets API developers combine policies and resources into a reusable group by capturing reusable functionalities in one place. A shared flow helps you ensure consistency, shorten development time, and more easily managed code. You can include a shared flow inside individual APIs, or you can go step further and place these shared flows as flow hooks to automatically execute your shared flow logic for every API deployed in the same environment as a shared flow. Injection is another major threat for an API. Untrusted injection of data such as SQL, NoSQL, XML parsers, ORM, LDAP, OS commands, and JavaScripts into API request can result in execution of unintended commands or unauthorized data access. Attackers will feed the APIs with malicious data through whatever injection vectors are available, such as direct inputs, parameters, integrated services, and so on, expecting it to be sent to an interpreter. Attackers can discover these flaws very easily when reviewing the source code using vulnerability scanners and fuzzers. A successful injection lead to information disclosure impacting the confidentiality and data loss, or in some cases it may also lead to denial of service. The best practice to mitigate injection errors or attacks is to include strictly defined data input such as schemas, types, string patterns, performing input validation, limit checks, and enforcing them at runtime. An API gateway, acting as a server for the incoming API request, checks to ensure that the payload structure falls within an acceptable range, and also known as limit check. You can configure an API proxy so that the input validation routine transforms the input to remove risky character sequence and replaces them with safe values. And this is where data loss prevention policies can come handy. For example, provide data loss prevention mechanism provided by Google Cloud or some other cloud provider. Now, insufficient logging, monitoring, and alerts allow attacks in progress to go undetected. And therefore, a strategy should be required to obtain insights over critical events that have impact over your business. A proper event and logging management strategy for APIs should be considered, and some of the best practices should be built for that. For example, a strategy for a log management policy. Document and enforce rules to standardize and control log verbosity, log level, log integrity, and centralized repository where your logs will be stored. Define a strategy for event management policy. Guarantee that every event should be traceable to its source. Also, events should be able to be categorized by criticality and business impact. Define strategies for your reports and audits. Security and operations stakeholders should be able to access and react to logs and events in real time. And additionally, reinforcement cycles should be defined for the performance of stakeholders to adjust detection and patterns based on historical data. That's the end of my presentation, and we have just scratched the surface of API security, and there are a lot more things to consider. Feel free to contact me or talk more in the platform networking area, and we can have much more deeper conversation about API security. And now let's pass the time to the MC. Thank you so much.
Thanks, Harish. So we will have another 20 minutes break. We will recount.
The API Connect Hong Kong 2023 conference is powered by bNovelty Limited. Check out more API-related education content on bnovelty.com or apidays.hk for more information.